Hi friends, in this session we'll start with the group number 16. In last session we already completed group 15, that is nitrogen as well as phosphorus compounds. So let's start with the group 16. The group 16 elements of this modern periodic table consist of these 5 elements, that is oxygen, sulfur, selenium, tellurium and polonium. The elements in this group are known as chalcogens family or the ore forming elements because many of these elements can be extracted from the sulfide or the oxide ore. Oxygen is abundantly found in earth. Estimated the proportion of these different types of atom found in universe. Oxygen was claimed as the 4th abundant element after the hydrogen, helium and neon. It constituted about 89% of water, 46% of earth crust and 20% in air. So you all aware about it. Oxygen is really very important for human being also. In chemistry, each and every reaction in the presence, combustion reaction in presence of oxygen, and lots of applications are available in this group. So सबसे पहले थोड़ा सा ग्रुप के एलिमेंट के बारे में इंट्रोडक्शन पढ़ लेते हैं, मीन्स ऑल द 5 एलिमेंट्स के बारे में 2 लाइन पढ़ लेते हैं. देन वी मूव ऑन टू दिस जनरल इलेक्ट्रॉनिक कन्फिगरेशन एंड फॉलोड बाय द फिजिकल प्रॉपर्टीज. So let's start each and every element step by step. First member is oxygen. The chemical symbol of oxygen is given as O. It is a colorless, odorless gas used in this respiration system by humans, which is converted into this carbon dioxide. Oxygen exists as a diatomic species, that is O2. Oxygen is also found in triatomic molecule, that is O3 in trace. It is known as ozone. Oxygen combines readily with many elements. During the combination with some elements, evolution of heat takes place and the process is known as combustion. So this is a brief introduction about oxidation. Next we move on to this sulfur. After oxygen, second element is sulfur. Sulfur is denoted by symbol S. It is a non-metal which rank 9th on the basis of this cosmic abundance. About 1 atom in every 20 to 30,000 atom is a sulfur atom. Sulfur is found in a combined state as well as in a free state. About 0.09% of sulfur is found in a seawater in a form of sulfates. Meteorite contain 12% of sulfur. A large amount of sulfur is found from this underground depositions of pure sulfur present into this dome-like structure. Here sulfur is formed by the action of anaerobic bacteria on sulfate minerals such as gypsum. So this is your introductory part of sulfur. After sulfur, next is selenium. Selenium is rarer than oxygen or sulfur. It is found in a free state as well as in a combined state with heavy metal like lead, silver, mercury. In a few minerals, grey metallic form of this selenium is the most stable form of element under the normal condition. Now एक और general knowledge का question, selenium dioxide. Where you found the highest amount of selenium dioxide? तो head and shoulder. Yes, selenium dioxide used as an anti-dandruff agent. So one of this application of selenium or selenium dioxide is it is used as an anti-dandruff agent used into this shampoo. Tellurium. Tellurium is a chemical element having the atomic number 52 and has the properties between the metal and non-metal. It is one of the rarest stable elements found in the earth crust. It is often found in a free state and compounds with the elements such as copper, lead, silver and gold. Last is polonium. Polonium is slightly radioactive in nature, so whenever we discuss the trend, we start with oxygen, we end with the tellurium. We don't include polonium in our trends just because of radioactive species. It is the rarest element among the group 16. It is a radioactive element. Polonium is sometimes used as a scientific application for this alpha radiation. So this is all about all the 5 members, that is oxygen, sulfur, selenium, tellurium and polonium. So without wasting much time, we moved on to this physical properties of chalcogens family, and first is electronic configuration. Okay, let's start the physical properties of chalcogens. First of all, general electronic configuration. General electronic configuration, these are group 16 element. General electronic configuration is noble gas, NS2 and P4. Oxygen has helium core 2s2 2p4, sulfur 3s2 3p4, selenium 3d10 4s2 4p4, tellurium 4d10 5s2 5p4, polonium 4f14 5d10 6s2 6p4. The general electronic configuration of chalcogens can be written as NS2 and P4, where N denote the value of the principal quantum number corresponding to the valence shell of this element. The electronic configurations of chalcogens are as follows. The electronic configuration of the synthetic element livermorium believed to be as a chalcogens. Chalcogens के नीचे अगर आप चले जाओगे तो last is synthetic elements, that is livermorium, is predicted as radon core 5f14 6d10 7s2. So let's start with atomic and ionic radii of chalcogens family. The atomic radii or the ionic radii of element increase while progressing down to the group. Once again, chapter 3, standard 11 concept. When you come up to the down, atomic number increases, molar mass increases, size increases, and due to this, atomic and ionic radii increases. The chalcogens with the lowest atomic radius and the ionic radius is oxygen. Obviously, just because first family member smaller in size, whereas the chalcogens with the largest atomic number and radius excluding livermorium is polonium. Livermorium को क्यों नहीं introduce करें? Just because it's a synthetic element. It can be noted that atomic radii of these elements decreases across the periods due to this addition of protons and the increase in this effective nuclear charges. Therefore, the atomic radius of oxygen will be much smaller than that of the lithium. अब सभी को पता था ट्रेंड एनालिसिस. लेफ्ट हैंड साइड पे चले जाओ लिथियम, राइट साइड पे फ्लोरीन. The size of lithium is much higher than the fluorine. Why? Because electron introduced into the same principal quantum number, due to this effective nuclear charge increases, size decreases. So lithium is larger in size, while in case of fluorine is smaller in size. Here in case oxygen is smaller in size as compared to this lithium. Next is ionization enthalpies of chalcogens family. Ionization enthalpy, minimum energy required to remove one electron from outermost shell is known as ionization enthalpy. जनरल इलेक्ट्रॉनिक कन्फिगरेशन से पता चल रहा है chalcogens family are always hungry for 2 electron to complete its nearest octet. But डाउन टू द ग्रुप चले जाओगे तो टेंडेंसी ऑफ गेनिंग 2 इलेक्ट्रॉन की जगह पे रिमूवल ऑफ 4 इलेक्ट्रॉन एंड 6 इलेक्ट्रॉन इंक्रीजेस. Maybe 4 electron increases just because inert pair effect. So oxygen does not want to release 4 electron, oxygen gain 2 electron. सल्फर के केस के अंदर भी ऐसा होगा, बट नीचे नीचे चले जाओगे तो सेलेनियम एंड टेल्यूरियम के बारे में बात करेंगे तो दे हैव पॉजिटिव ऑक्सीडेशन स्टेट. So let's start with ionization enthalpy. As the size or the radius of this atom increases, ionization enthalpy decreases. It is easier to remove an electron from an atom with this larger atomic radius since the distance between this nucleus and the valence shell is relatively large. हमने बहुत सारे एग्जाम्पल पढ़े थे. Let's take example if you want to remove one electron from lithium and one from cesium. Cesium can easily released. Why? Just because cesium is far away from this nucleus, larger in size. Attraction from nucleus to outermost shell is really very less, and due to this cesium can release one electron. Therefore, the ionization enthalpies of this chalcogen family decreases while this the progressive down to the group. Oxygen has highest ionization enthalpy among the chalcogens. It can also be noted that ionization enthalpy increases with progressive across a period due to this increase in this effective nuclear charge across the period. Therefore, ionization enthalpy of oxygen will be much higher than to this lithium. So down to the group भी discussion कर लिया, across the period भी discussion कर लिया. इसके बाद electron gain enthalpy. Electron gain enthalpy. As the size of atom increases, the electron gain enthalpy decreases. Therefore, the electron gain enthalpies of this chalcogen family decreases down to the group. Most important one marker question. It is important to note that oxygen has a less negative electron gain enthalpy as compared to the sulfur. यहाँ पे exceptional cases आएगा, याद रखिएगा. Just because oxygen is smaller in size, very high electron negativity, due to this reason oxygen से sulfur की electron gain enthalpy ज़्यादा है, which can be explained by this compressed atomic structure of oxygen, which contributes to this inter-electronic repulsions between this valence electron and any another approaching electron. So this is all about your electron gain enthalpy. Next is electron negativity. Electron negativity decreases with progressively down to the group due to this many factors such as increase in atomic radius, increase in electron repulsion. The most electron negative सबसे हाईएस्ट कौन है? फ्लोरीन. और फ्लोरीन के बाद नेक्स्ट कौन सा आएगा? ऑक्सीजन. बट डाउन टू द ग्रुप चले जाओगे तो इलेक्ट्रॉन नेगेटिविटी कम होती जाएगी. क्यों? 2-3 रीजन है, जैसे हमने डिस्कस किया. साइज बढ़ती जाएगी, इलेक्ट्रॉन रिपल्शन जो है वो कम होता जाएगा. एंड दूसरा एक मोस्ट इंपॉर्टेंट मेटालिक कैरेक्टरिस्टिक्स इज ऑल्सो इंक्रीजेस. टॉप मोस्ट फैमिली मेंबर जो होंगे वो क्या होंगे? नॉन मेटल. मिडल वन इज मेटलॉइड एंड सबसे लास्ट हो गए वो क्या हो गया? मेटल. सो chalcogen, oxygen and the least electron negative chalcogens is polonium. लिवरमोरियम को हम कंसिडर नहीं कर रहे हैं. नेक्स्ट इज मेटालिक नेचर. अभी हमने डिस्कस किया. ऑक्सीजन एंड सल्फर आर क्लासिफाइड एज अ नॉन मेटल्स. Selenium and tellurium are classified as metalloid, and under the standard condition polonium exhibit the metal characteristics. So topmost two family member non-metal, middle one is metalloid and last जो था metallic character. However, it is important to note that polonium is radioactive in nature. After that, we'll discuss melting point and boiling point. Trends in melting point and boiling points of chalcogen's family. Due to the increase in atomic sizes and atomic mass down a group, the melting and boiling point of element is also increases. While progressive down to the group, among the chalcogens, oxygen is known how to be the lowest melting and boiling point. The considerable difference in the melting point and boiling point of sulfur and oxygen can be explained by the fact that oxygen exists in atmosphere as a diatomic molecule, whereas sulfur exists in a polyatomic molecule. S6 and S8 are available, and due to this melting and boiling point is this difference. So this is all about your physical property. यहाँ तक सारी की सारी प्रॉपर्टीज फिजिकल प्रॉपर्टीज के अंदर थी. नाउ वी मूव ऑन टू दिस केमिकल प्रॉपर्टीज. सबसे पहला एन इंपॉर्टेंट पॉइंट डिस्कशन कर रहे हैं ऑक्सीडेशन स्टेट. जो अगर आपको ऑक्सीडेशन स्टेट अच्छे से पता है तो सारी की सारी रिएक्टिविटी उसी से पता चल जाती है. reaction with oxygen, reaction with hydrogen, reaction with halogen and many more reactions are there. So इसी के लिए ऑक्सीडेशन स्टेट पढ़ना बहुत ही ज़्यादा ज़रूरी है. So without wasting much time, let's start with the chemical properties of chalcogens family. उसके अंदर first point, oxidation state. The elements of group 16 exhibit a number of oxidation state. मैंने पहले ही बताया टॉप मोस्ट फैमिली मेंबर ऑक्सीजन हैविंग -2. ऑक्सीजन के और भी ऑक्सीडेशन स्टेट है फ्लोरीन के साथ जो उससे भी ज्यादा इलेक्ट्रॉन नेगेटिव है, वहां पे पॉजिटिव हो जाएंगे. बट डाउन टू द फैमिली मेंबर +2, +4 एंड +6 ऑक्सीडेशन स्टेट में है. लेट्स स्टार्ट. द स्टेबिलिटी ऑफ -2 ऑक्सीडेशन स्टेट डिक्रीजेस डाउन टू द ग्रुप. Polonium hardly shows -2 oxidation state since electron negativity of oxygen is very high. It shows only negative oxidation state as -2 except in the case of OF2 where it is oxidation state is +2. Just because oxygen is associated with fluorine which is more electron negative जहाँ पे +2 है और दूसरा एक भी component है O2F2 जहां पे ऑक्सीजन का +1 हो जाएगा. बाकी सारे केस के अंदर जनरली -2 है. ये सारा डिटेल डिस्कशन रेडॉक्स स्टैंडर्ड 11 में पढ़ा था. जैसे पैरोक्साइड के अंदर -1 है, सुपर ऑक्साइड है और बहुत सारे और भी कंपोनेंट है जहां पे इसका ऑक्सीडेशन स्टेट एक्सेप्शनली चेंज हो जाता है. अदरवाइज बाकी सारे स्पीशीज के अंदर उसका ऑक्सीडेशन स्टेट हो जाएगा -2. Other elements of this group exhibit +2, +4, +6 oxidation states. But +4 and +6 are more common. +4 and +6 are more common. उसमें भी +4 ज़्यादा फिजिबल होगा. क्यों? इनर्ट पेयर इफेक्ट. Np4 के 4 इलेक्ट्रॉन निकल जाएंगे. +6 कब बनेगा? NH2 + Np4 दोनों के दोनों इलेक्ट्रॉन निकलेंगे तब +6 बनेगा. Sulfur, Selenium and Tellurium usually shows +4 oxidation state in their compounds with oxygen and with +6 with fluorine. SF6 extraordinarily stable just because fluorine is more electron negative species and accommodate from the sulfur 6. The stability of +6 oxidation state decreases down to the group and the stability of +4 increases just because inert pair effect. Inert pair effect का मतलब down to the group NS2 means s ऑर्बिटल के 2 इलेक्ट्रॉन निकलने की टेंडेंसी बहुत कम हो जाती है. दैट इज एंटाइटल्ड एज इनर्ट पेयर इफेक्ट. बॉन्डिंग इन +4 and +6 ऑक्सीडेशन स्टेट इज प्रिलिमिनरी कोवैलेंट इन नेचर. सो दिस इज ऑल अबाउट योर ऑक्सीडेशन स्टेट इन कैल्कोजेंस. अब इसके बाद और भी बहुत सारे रिएक्टिविटी चेक करनी है बट इन दिस सेशन विल एंड हियर. नेक्स्ट सेशन यहीं से आगे बढ़ेंगे. केमिकल प्रॉपर्टीज ऑफ कैल्कोजेंस एंड डिफरेंट केमिकल रिएक्टिविटी चेक करेंगे. थैंक यू.